Hello everyone, and welcome to our first class of statistics this semester. Again, I just want to welcome everyone to the class and talk a little bit about what it is that we're going to be doing this semester. Obviously, we are going to be talking about statistics this semester and talking about the importance associated with statistics, and also discussing how statistics are calculated and how they're applied to research questions that we may have in terms of the field that we're pertaining to. Specifically, a lot of my examples will be in regards to the field of psychology, but that's not necessarily always true. If those of you who are coming from social work or from computer information systems, you may have research questions yourselves in regards to some specific research design that you're setting up or research questions that you're wanting to explore. And the use of statistics is going to be very helpful because it's going to be able to provide you with a specific response or a specific answer associated with your research question. So in terms of introducing statistics this semester, I do want to begin by introducing some very basic symbolic notations. But before I actually begin introducing the symbolic notations, I do want to discuss just very briefly with you the importance associated with statistics and why it is that we're taking statistics as a class. Now, I asked everyone to complete last week for Module 1 the survey that I had posted online in regards to your attitudes of statistics. Now, one of the major findings that we found throughout the survey itself, even with the individuals who did respond, is the following. We find that individuals, number one, are somewhat hesitant about statistics. That's a very normal thing. And two, a lot of people are taking statistics, some of them out of their own free will, but also many of them are taking statistics because it's a requirement for either their major or for their minor. Now, that's not something that's in particular to students here from Our Lady of the Lake. That's actually something that we find throughout the entire world in terms of pretty much any statistics class that comes down to the behavioral sciences. Normally what we find is that students are quite hesitant to actually register themselves for a statistics class, and then imagine for an advanced statistics class or an intermediate statistics class, a lot of individuals won't even register for those. But in the reality of the situation is that many students don't want to take statistics because they have this huge fear that there's going to be so much mathematical information that's going to be presented to them, or that it's going to be so complicated or so difficult to understand that they rather not even do it. They assume that statistics in itself is going to be something very similar to trigonometry or to calculus or to geometry or something like that. But in reality, statistics isn't that at all. Granted, all of those different courses do deal with numbers, and so does statistics, but the way that we view statistics in our world is very, very different than the way we view mathematical equations and mathematical processes within the math field. Statistics in itself is its own beast, if you want to think of it in that capacity, and it's something so wonderful for us that once it is that we understand how the statistics work and how or what their function is, that is very, very useful for us. So again, what's the purpose of statistics? The purpose of statistics is really to provide us an answer. What answer is it that it's going to provide us with? It's going to provide us with the answer to our research question. So for instance, you may have a question like, how am I going to do in a particular class, right? So let's say, for instance, that you've taken exam 1, exam 2, and you want to know how you're going to perform on exam 3 for that particular class. A really good way to be able to assess or to predict your ability to perform on exam number 3 based on exam number 1 and exam number 2 is to take an average. That's actually one of the things that I do for all my classes, that at the end of the semester, students will normally ask me, sir, you know, I've been doing all these things, how am I going to perform at the end of the semester in terms of the final exam? I normally take the exam 1, exam 2, average them out, and that's normally a pretty good predictor of exam 3 performance. Sometimes we may be off just by a little bit, but in reality it's quite accurate in its representation, and I'm going to talk about some of those issues in the next coming sessions in regards to why things like the average are such an important predictor of performance. So let's now move into talking about the symbolic notation that we're going to be covering this semester. So in terms of our symbolic notation, number one, I'm going to begin with what we call our score or our data point. This is always represented by the symbol X. The letter X, or the symbol X for us, capital X, always represents a score that we've calculated or a data point that we've collected data on. So let's say, for instance, that you take an exam and you score on that exam an 82. That's your X score. right? Or that's X represented for that one single participant. So think of, for instance, the number of aggressive acts committed in a classroom setting, right? Or let's think about how many helpful acts somebody commits during a 24-hour period, whatever the case may be. So if we look at it for participant number 1, that person completed 3 acts. Participant number 2, 15 acts, and participant number 3 completed 5 acts. So each one of those participants receives a score, or an X value. So the X value for participant number 1 is going to be equal to a 3, X is going to be equal to 15 for participant number 2, and X is equal to 5 for participant number 3. The second symbol here that I want to introduce is the summation sign. It almost looks like a really fancy letter E, but it's really here our summation sign. Essentially what the summation sign tells us to do is to sum up our scores. So very simply here, whenever it is that we see the summation sign, we do whatever's after the summation sign, or we're going to sum up whatever comes after it. So in our particular case here that I give as an example, sum up X. So referring to our previous example here, so we have our numbers 3, 15, and 5. If we add all those values up, that should give us a value of a 23. Okay? So again, that's 15 plus 5 is 20, plus 3 is now going to be 23 in our particular case. So very, very simple. The summation sign, just add up whatever it is that we're going to be dealing with after the summation sign, in our particular case, the X value. Next, for instance, we're going to have our parenthesis. Our parenthesis is very important for us. So here, if you've ever thought about orders of operations, so when you took basic math, when you were in high school or even in college, you did basic order of operations. And essentially what the basic order of operations always says is do whatever's in parentheses first. Think about that like in basic algebra, right? So here, we always do whatever's in parentheses first. So in our particular case here, we have 2 plus 3, which is in parentheses, so we're going to do that first. So that's going to give us a value of a 5. Plus, now within the next parenthesis, 5 times 3. So here, we added 2 plus 3, giving us 5. And now we're going to do 5 times 3, which is 15, giving us a total of 20. So we did 5 plus 20, or 5 plus 15 equals 20 in our particular case. Now next, you'll also see the aspect of square rooting or squaring in our particular cases in many formulas. Very simple here. You'll normally see the letter X with a square sign next to it, or even a letter Y with a square. Don't worry if you ever see a Y. Y essentially also represents the same thing as a score. So rather than just writing X, sometimes we write Y. And the reason for that is that, let's say, for instance, we're calculating 2 scores. Let's say that we were calculating the number of aggressive acts committed in class. We're going to label that as X. And now we want to look at the number of helpful acts committed in a class. We're going to label that as Y. So one score represents X, another score represents Y, so that way we can differentiate between the 2 acts that are being committed. One for aggressive acts, which is X, and one for helpful acts, which is going to be Y. So in our particular case, we have our score squared. So essentially, this means just square your score. So on your calculator, you find the function that looks just like we have here, which is the X with the little square with the superscript 2 in our particular case. And all we do is, in our particular case, 3 squared equals 9 in our particular example here. Next, you're also going to find the letter N used very frequently in terms of symbolic notation in formulas. There is a differentiation between little n and capital N. Little n always refers to the number of scores and or people from your sample. And we're going to talk about this issue of a sample in just a couple of minutes here. But N is a very important symbolic notation that we always have to keep present in our mind whenever it is that we're doing formulas or we're working with statistics. So again, little n represents the number of scores and or people that come from your sample. That's very important. So little n comes from sample. How many people coming from the sample? Very, very important. Now you also have capital N. And capital N refers to the number of scores and or people from your population. So you'll notice here that the only differentiation between those 2 definitions between lowercase n and capital N are lowercase n, number of people from your sample, capital N, number of scores from your population or number of people from your population. So as the semester progresses, we're going to talk a lot about all these symbolic notations, and we're specifically going to talk about this issue of samples versus populations a lot during the semester. So this is a key issue that we all need to understand prior to continuing on throughout the course. And I'm going to talk about this issue of populations versus samples in just a bit. So let's say that we're going to work through a little bit of a sample problem here. I promised you all that throughout the semester I was going to give you guys lots of examples and lots of samples for examples that you all can do at home. And here you can follow along with doing this. So if you do have your calculators with you, I would recommend just following along. So let's say, for instance, again, we're looking at this example of number of aggressive acts committed in class. Let's say, for instance, you're taking a statistics class. I don't know why you would do that, right? But maybe you're taking a statistics class. And in that statistics class, people are starting to get frustrated, and we want to count how many aggressive acts occur in the class as time progresses within the course itself. So on first day of class, second day of class, third day of class, fourth day of class, so on and so forth, we're always going to be measuring the number of aggressive acts that are committed within a class. So in our particular case, we're going to measure people on the very first day of class or on the second day, whatever it is that you choose. So here, these are our scores. So again, remember that this value here, a 4, represents for one single participant. So let's say, for instance, that's participant 1, that's Mary. The value of a 2, that's going to be Steve's score. The value of a 3, that's going to be Mark's score. And the value of a 5, that's going to be for our fourth participant, that's going to be for Ginger's score. So ultimately here, you have 4 different participants. Each one of them gave you an aggressive act score. Okay? So again, participant number 1 gives you a value of 4, participant number 2 gives you a value of a 2, participant number 3 gives you a value of a 1, and participant number 4 gives you a value of a 5. So here, if we wanted to calculate sample size, so again, n, because remember, lowercase n refers to sample size, not the population, but the sample size. So ultimately, how many is that? So in our particular case, these are all the individuals that participated in my study. So these are the number of people that I actually calculated their scores for. So in terms of n, this represents the number of scores that we actually have. So again, remember that, the number of individuals that participated in my study, or in my particular case, the data collection procedure I just took upon. So what does this mean for us? It means that n equals, in our particular case, 4. Because again, we have 4 data points, so the value of a 4, 2, 1, and 5. Each one counts as one participant, giving us a total of 4 participants that come from our sample. Okay, so n equals 4. Next, we're going to find the sum of scores. So here, go ahead and try that procedure. So again, remember, look back on your notes. What does the summation sign actually do? So here, we're going to find the sum of x. Okay, so very, very important. So again, the sum of x. So remember, the summation sign means to sum up whatever comes next. So we're going to sum up x scores. We're going to talk about the answer in just a minute here. Next, we're going to find x plus 1 for each score. So again, what you're now going to do is you're going to plug in each x value into that equation right there that we have. So 4 plus 1, 2 plus 1, 1 plus 1, and 5 plus 1. You're going to do this for each one of them. So you should have 4 answers for number 3. Okay, so for question number 3, you should have 4 responses. So there should be a response for 4 plus 1, 2 plus 1, 1 plus 1, and 5 plus 1. So again, very, very importantly, whenever it is that we see something like we are seeing here, since x represents for one single score, we need to plug in each value in our data set into my equation. So go ahead and do that. So again, you should have 4 scores for number 3. Now, let's do number 4. So find x plus 1 squared. So remember, follow orders of operation, and you're going to do what's in parentheses first. So again, x plus 1. So here, going back to your previous example, you've already done that, right? You already have your 4 answers there. So now all you have to do is your 4 answers that you calculated for number 3, square them. So let's say, for example, 4 plus 1, like you had in the previous example, which would be equal to 5. Now this is going to be 4 plus 1, which again is 5. Now square that. Okay? You're going to do the same for all your other responses. So for 2 plus 1, for 1 plus 1, and for 5 plus 1. Last, we're going to sum up x plus 1 squared. So again, you've already done number 4, right? So again, remember, we always do what's in parentheses first. So again, here, x plus 1. So again, 4 plus 1, 2 plus 1, 1 plus 1, 5 plus 1. We're going to now square each one of them because, again, following orders of operation, we always do what's in parentheses first and then what's right next to the parentheses on the right-hand side. But now we're going to sum all those squared products that you actually just calculated. So again, so 4 plus 1 squared, right, which is going to give you an answer, 2 plus 1 squared, 1 plus 1 squared, 5 plus 1 squared, and now we're going to sum up all of those values that you've already squared. So let's look at our answers here. So for number 1, our answer should be a value of 4. So our sample size was equal to 4. Remember, we had 4 participants, 4 data points. So that gives us a value of 4. For number 2, we should have a value of 12. So when we summed up our scores, we should get a value of 12. So again, looking back at your scores, 4 plus 2 is 6, plus 1 is 7, plus 5 is equal to 12. So now we're going to look at number 3. So again, x plus 1. So 4 plus 1 equals 5, 2 plus 1 equals 3, 1 plus 1 equals 2, and 5 plus 1 equals 6 in our particular case. So these are your 4 answers that you should have gotten for number 3. Now looking at number 4, so all now we're going to do is we're going to take these 4 answers that you have from number 3 and we're going to square them. Because remember, for number 4, the equation requested x plus 1 squared. So now 5 squared equals 25, 3 squared equals 9, 2 squared equals 4, and 6 squared equals 36. Now last, what we're going to do is we're going to sum up our scores. So we're going to add up all of our scores to see what it is that we actually get. You should have received a value of a 74. So again, 25 plus 36 should give you a value of a 61, plus 9 should give you 70, plus 4 is 74. So again, here we have done x plus 1 squared. So again, 5 squared, 3 squared, 2 squared, 6 squared, and we added all those values up to give us a value of a 74. If you were able to follow along with this, and I haven't lost you, and if I have lost you, rewind, do it all over again, so that way you can see the entire procedure that we actually took upon here. But if you were able to keep up with this, you've essentially mastered 3/4 of a statistics, to be honest with you. I mean, I'm not lying to you in that particular instance, and some of you may be saying, no, it's a lot harder than this. Not really. If you can follow along with this, you've essentially done the basic formulas for pretty much all statistics that we actually have out there. All that you really have to do is just plug in the right numbers in to the formula and follow the right procedures. If you're able to do that, you're going to be solid. So if you're able to keep up with this, you're in good hands. If you haven't been able to keep up with this, like I say again, rewind, ask me questions, email me, feel free to IM me through Blackboard IM or whatever the case may be, and I'll be happy to respond to your questions. Okay, so now let's look at some basic terminology that you guys are going to start finding throughout the semester. And here I'm going to introduce some very basic terminology that we're all going to have to become familiar with, but then as the semester progresses, we're going to find a lot more terminology that we have to encounter and that we have to familiarize ourselves with. So the first term that I want to introduce you, and again, this refers now to the aspect of capital N in terms of that symbolic notation, is this aspect of a population. Very, very important term that you're going to encounter in psychology and pretty much in any research discipline. You're always going to hear the term population. What does the term population mean? It means the entire group of people who have similar characteristics. So it means everyone. Let's say, for instance, I'm interested in Spanish-English bilinguals who are Hispanics and who are females. That means that everyone who fits that specific parameter of Spanish-English bilinguals who are Hispanic and who are females fit into that category. Okay, they're my entire population. Now, who's not going to be a part of that population? We're not going to have Spanish-English bilinguals who are Hispanic who are males. So the males don't count because that's not who we're interested in. I'm only interested in people who are Spanish-English bilinguals who are Hispanics and who are females. Now, think of that for a second here. Just this population here that I'm talking about, Spanish-English bilinguals who are Hispanics who are females. That's a very, very large number of individuals. Let's say that you're doing a research study and you wanted to have them participate. Think of that population. Is it realistic that you're going to get everyone from that population to come in and participate? Think of that for a second. Is that realistic that you're going to get all Spanish-English bilinguals who are Hispanics who are females to come in and participate? Hopefully you should be saying to yourself, no, that is not likely. It's virtually impossible. And you're absolutely right. If anything, it's never going to happen, to be honest with you. And we're okay with that, to be honest, as researchers. As researchers, we've come to the conclusion throughout years and years and years of experiences of us doing research that we're really never going to get the entire population to come in and participate. That's very unlikely. The only way that you would ever get the population to come in and participate is if you were to limit so much your parameters to specifically say one group of individuals. Let's say, for instance, we are interested in Spanish-English bilinguals who are Hispanics, who are females, who attend Our Lady of the Lake University, and who are enrolled in an online statistics course in the fall semester in psychology. Okay, so now your population, rather than being millions of people, now boils down to being a couple of dozen people. So you may have 24, maybe 36 people who might participate and who might fit that parameter of being the population. So now I've limited so much in terms of who I'm looking for that I've made my population to be this small, right? So rather than it being this wide, it's now become this small. So why is that important to me? Why do I care so much about the population? So why wouldn't I want to make it this small? Well, think about this. Think about the characteristics that Spanish-English bilinguals who are Hispanics, who are females, who attend Our Lady of the Lake University, and who are enrolled in a psychology statistics course in the fall of 2015, why would I not really want them just to be my sole participants? Well, what does the rest of the population look like? So let's say, for instance, you wanted to apply your research findings using those individuals that you just talked about, but to all other Spanish-English bilinguals who are Hispanics, who are females. So in other words, using the people from Our Lady of the Lake who fit Spanish-English bilinguals who are Hispanics, who are females, who are enrolled in a statistics psychology class for fall of 2015, why wouldn't I just want to use them to then talk about all Spanish-English bilinguals who are Hispanics, who are females? Well, because those individuals who are Spanish-English bilinguals, who are Hispanics, and who are females may not have the same qualities or characteristics that the people who participated actually have. So in other words, out there in the population, Spanish-English bilinguals who are Hispanics, who are females, may not all attend college. They may not all have the same level of education. They may not all have the same qualities in terms of learning techniques, et cetera, et cetera, et cetera. So now the people that I used in my study may be a little bit different than the actual people out there in the real world. And what I want to try to do is I want to try to get people who are a good representation of the entire population. So if I were to just care about Spanish-English bilinguals who are Hispanics, who are attending Our Lady of the Lake University, who are enrolled in statistics and psychology for fall of 2015, and those are the people that I use, awesome. But if I care about all Spanish-English bilinguals who are Hispanics, who are females, using just those individuals that I talked about are probably not going to be a good representation of the entire population. They may be adequate, but they're not going to be great. And that's what I really want. I want to have a great representation, because what I'm going to end up using in my research studies and to calculate my statistics, I'm going to be using samples. So I'm going to be using lowercase n. What are samples? Samples are the subset or a selected group of individuals that come from the population. So in other words, I care about Spanish-English bilinguals who are Hispanics, who are females. Okay, that's my target population. Too many people fit that characteristic or fit that population. So what I'm going to do is I'm going to select a group of people. So that population, let's say for instance, is 1 million individuals. Okay, it's probably more than that, but let's just say for now it's 1 million people. So what I'm going to do, rather than trying to get all 1 million individuals to come in and participate, I'm going to randomly select, let's say 100 or 200 of those 1 million to come in and participate. Now, this is a very, very important issue. If I'm going to sample from the population, because that's the term that we use for when it is that we take individuals from the population to come in and do my study. If I'm going to sample from the population, if I'm going to calculate my sample, if I'm going to get them, where am I going to get them? Think about that for a second. So I'm a psychology professor at Our Lady of the Lake University, and I need participants. Where am I going to get them? Think about that. More than likely, you're thinking to yourself, okay, you're a psychology professor at Our Lady of the Lake University, and you need participants. Well, you're probably going to get them from the university. You're exactly right. And that's exactly where I'm going to get them from. And more specifically, I'm probably going to get them from my classes, right? So if I need people to come in and participate, one of the ways that I can do that is I can probably offer extra credit. And I can say, hey, if you want to come in and earn 5 points extra credit on your class, let's say for instance, right, as an example, I need participants. So why don't you come in, give me your data, and we're going to be good, and you're going to get your 5 points. That's one way for us to be able to do that. And that would be a really efficient way. Now, to be honest, that's not what we call true random sampling, because that's the ideal thing, that we would give everyone from the population an equal opportunity to participate. True random sampling. Giving everyone from the population an equal opportunity to participate. Okay. So I'm probably not going to do that. So I'm probably going to go to my classes and sample from them. What am I going to call that? The term is not very creative, but the term is actually called convenient sampling. And why? Because we're going to sample from a place that's convenient for me as the researcher. That's why we call it convenience sampling. So in other words, I'm going to get people from the population, right? I assume they're going to come from the population, from a place where I have easy access to them. So thus, they're going to come in and participate and give me their data because I have easy access to them, right? In a real ideal situation, what I should have done is I should have given everyone from the population an equal opportunity to participate. That's what I really should have done. I should have asked everyone from the population, all 1 million people, hey, who wants to come and give me their data? And then whoever I get to come in and participate, that should have been the data that I look at. It's probably not going to be the entire population, but it's going to be a sample of it anyways. That would be the truest way for us to do random sampling. Is that going to happen? No. And why is it going to happen? For a variety of reasons. Number one, how do I get in contact with everyone from the population that I need? So how do I get in contact with all Spanish-English bilinguals who are Hispanics who are females? Do I send out Facebook requests and Facebook posts? No, because some of you are thinking, man, who uses Facebook anyways, right? Only old people. I still use Facebook, so I must be in that category. So some people don't even use Facebook anymore. Okay, we're going to send tweets out and see who answers that. Do all Spanish-English bilinguals who are Hispanics who are females have Twitter? For instance, my mother is a Spanish-English bilingual. She's Hispanic and she's female. She doesn't have Twitter, so I'm not going to get her, right? That's unfortunate. So do I send them emails? Do I try to call them? Do I send them text messages? Do I send them letters in the mail? So all of these different procedures that I'm doing, are all of them going to guarantee me that everyone's going to respond and everyone's going to have access to that and then they're going to have the ability to respond back to me? No, it's not. So in reality, no matter what procedure I use, it's never going to be true random sampling because I'm still going to miss people. Because here, remember, we're saying Spanish-English bilinguals who are Hispanics who are females. So what if these are individuals who live in Puerto Rico, or they live in Brazil, or they live in Chile, or wherever it is that they are? Are you going to go all the way over there to contact them also? Probably not, because you're going to be limited by resources. So rather, what are you going to resort to? Again, convenient sampling. Because again, that's going to be low cost to you, and it's a very quick way for us to get data, and then we can continue on doing more studies and more studies. It's an unfortunate reality in terms of us doing research in psychology and in the behavioral sciences as a whole, but that's the way that we do it. And we do so unforgivingly. So at the end of the day, when I do research that way, I don't go home crying to myself saying, oh no, I really didn't do true random sampling. People are going to think negatively of my work. No one's really going to care, to be honest with you. If you look at research articles that use individuals as participants, over 90% of published psychology research uses general psychology students as their population or as their samples. So in other words, people who are taking general psychology classes or intro to psychology, they are the people who then go and participate in research studies, and those are the people that we then use, or that's the data that we use to then publish. So we've been doing it for years and years and years. We're not going to stop doing it, to be honest with you. True random sampling is virtually impossible for us. So in reality, we resort to the aspect of doing convenient sampling. So again, the differentiation between populations and samples. Populations, everyone from the population who has the characteristic of interest. Samples, just a subset of people who have that characteristic, and we're going to try to have easy access to them or just access to them as a whole. Okay, so now we're going to look at some other terminology. The issue of qualitative versus quantitative data. Very, very important in terms of statistics and in terms of data collection. Because think of this in terms of what we're doing this semester with statistics. Statistics is the way that we answer questions that we have, our research questions. So in other words, we're already talking about research methods. That's the next class that you guys are probably going to be able to take, which is this class of research methods. In reality, in an ideal world, we would teach stats and research methods simultaneously. And why? Because when we design research studies using research methodology, so what you're going to learn in research methods, we then use statistics to test predictions that come from research questions. So in other words, is there a difference between psychology and sociology students in terms of their statistics grades at the end of the semester? That's my research question. I'm now going to make a prediction. Psychology students are going to have a higher grade at the end of the semester. Let's just say, for instance, right? So that's my prediction. Okay, so now I have to collect the data. So I have to collect data from people who are sociology students, people who are psychology students. Now I'm going to compare their scores to see if there are any differences between them. And let's say, for instance, I don't find differences between psychology and sociology students, right? So their averages at the end of the semester are very similar, an 84 and an 83, right? So no real differences between the two groups. Perfect. Now the statistic that I use to see if that difference is extreme or not extreme is now going to give me the answer to my question. So I didn't really find a difference between them. So now my prediction, so psychology students would perform better, is not supported. My research question, who performs better, psychology or sociology students, is answered as well because they both perform equally. Okay, so does everyone see that continuation? So here we have a research question, we make a prediction, we calculate statistics, then we go back, we test our prediction, and we answer our question. So here, statistics is a vital piece of information for us. Now, to put this in the framework of what we're talking about with qualitative and quantitative data, very important. Qualitative data means the following. We have verbal or narrative responses, okay? So in other words, when you ask someone, how are you doing today? And that person says, well, I'm doing just fine. Everything's going okay. I mean, everything is somewhat fine. I mean, I was in the hospital yesterday, but I'm feeling okay. But everything is really just kind of, you know, I don't know. It's just fine, whatever. So right there, that's a qualitative response that they're giving you. Now, that was a lot of things I said very, very quickly. So you, as the person who asked them that question, you now have to evaluate what they said. So we're going to create two categories. So category 1, they feel fine. Category 2, they don't feel fine. So out of everything I just said, where am I going to fit? Category 1 or category 2? I said things like, I feel great, I feel fine, I feel okay, I'm good. But then I also said, oh, well, I was in the hospital yesterday. I didn't really feel that well. I feel kind of like, where's go, right? I mean, does it go into bad? Does it go into good? Does it go in the middle? Should I create another category? So with qualitative data, as you all can see, it becomes very, very messy. One of the benefits of using qualitative data is that it's rich in detail. So think of this. On average, humans, a normal human, can produce somewhere between 400 and 450 words per minute. Per minute. So let's say, for instance, you were going to interview somebody. So for those of you who are interested in clinical psychology, and you're going to interview somebody, right? And you're going to now do research from that interview. So you're going to calculate, you're going to, gather qualitative data, right? Because you're going to interview them. It's part of the interview process, right? That we have open-ended responses. So here, now I have to deal with the following. I'm going to ask you a question like, how's everything going? And I'm going to let you go with it. So you're now going to talk and talk and talk and talk and talk. Maybe you're going to talk for 45 minutes. Maybe you're going to talk for an hour. At 400 words a minute? That's a lot of words, isn't it? So now you have to sift through all of that, and you have to make sense of it all. So think of it like an essay question, right? So we've all taken essay exams, right? So let's say, for instance, somebody asks you a question as an essay exam. What's the first thing that you do? You try to add as much fluff to that question as possible, or to that answer as possible. And why? Because you hope that throughout all of that information that you're providing, hopefully you're going to get the right answer, right? Okay, everyone does it. I'm guilty of it. We all do it. That's fine. As a person who's evaluating that, so now you turn the tables, right? You're the person who's reading somebody's essay response. You now have to sift through all of that and make sense of it all, right? So it's all this stuff that you're like, nope, 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 don't care, don't care, don't care. Okay, that might be a little bit important. Nope, 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 a little bit important. Right here, that's the answer. They got it. But I have to sift through all of that. The same thing is happening with qualitative data. It's a lot of information that we then have to sift through and do something about that. Now, the bad thing about qualitative data is that sometimes it's too much information, right? And with qualitative data, it's not easy for us to be able to apply numbers. How do I apply a number to a verbal response like, I feel okay? I mean, what's the verbal response that you give them? You're probably not going to give them a verbal response. So what's the other alternative? The other alternative is collecting what we call quantitative data. These are numerical responses or numerical data. So for instance, the survey that I just gave you all, the one about your attitudes towards statistics, this is essentially a quantitative data collection tool. Okay? So in other words, you selected from a scale from 1 to 5, strongly disagree to strongly agree, your responses, right? So I'm here, on purpose, or I'm here out of my own free will in statistics. Perfect, right? It's a great question here that we're going to have, and you're going to answer from a 1 to a 5, and you answer a 5. Perfect. So strongly agree. So you're here out of my own free will. You answered a 5. Strongly agree. Does that really capture, though, your attitude? Think about that, right? So you answered a 5. Does that really capture your attitude about how you feel about statistics, that you're here out of your own free will? So I strongly disagree. Rather, you really wanted to say, yeah, I totally registered for this class on my own. I really want to take it. I'm really looking forward to it. If I were to let you do that, it's a qualitative response because I'm allowing you that freedom and flexibility to give me that narrative response. But here, essentially what I've done is I've limited you. And I've given you a parameter, and I've said between a 1 and a 5, that's all that you can answer. You cannot say anything more. It's either a 1, 2, 3, 4, 5, and that's it. Well, what if you answered a 3? So neither agree nor disagree. How do I interpret that? How do I explain that to somebody else? Okay, so Susan here, she, out of her own free will, she neither agrees nor disagrees that she's here. Give me an interpretation for that. It's not easy, right? So when you're thinking about it, you're like, I don't know, right? Well, she's not really here because she's out of her own free will, but she's really not here either as a requirement. Okay, but what does that mean? So then why is she here? Again, right? So we have some of the issues with quantitative data. So the benefit of qualitative, you have lots of information. Disadvantage, we have lots of information, really cannot apply statistics or numbers to it. Quantitative, advantage, very quick to gather that data. So for instance, survey, very quick method of gathering that data, right, of using that survey. The disadvantage of quantitative data, though, is that sometimes we lose the meaning. We lose that detail. So here, an answer of a 5 isn't really a 5. It may have been a 7 or a 10, but we didn't allow a person that flexibility. I'll give you another example of this. Many years ago, I had a friend of mine who was working on a survey, and one of the questions that she had on her survey, or one of the statements said the following. Today I feel, and it went from a scale from a 1, which was I feel very sad today, to a 5, I feel great today. And in 3, it said I have middle feelings. I don't know why she wrote middle feelings, but she wrote middle feelings as the midway point in the survey. So that was a 3. So a student, a participant, responded with a 3. So we all sat there looking at her, and she responded with a 3. So in terms of how she feels today, she has middle feelings. Like, what does that even mean? So we asked the student, right? We asked the participant, we're like, can you kind of elaborate a little bit on that, right? So we're dealing here with quantitative data, right? So she gave us a number. She gave us a 3. And we tried interpreting that as best as we could. She has middle feelings. But it really wasn't meaningful to us. So now we ask her, can you kind of explain that to us? In other words, we're now wanting to get qualitative data. And she says, well, I don't really feel like, but I don't really feel like, And we all looked at her going, I have no idea what even any of this means, to be honest with you. So we were all extraordinarily concerned as to what it was that she was meaning behind all of this, because it's not really meaningful to us. Sorry, I clicked escape on that, sorry. So we lost a lot of that meaning. So if we would have just gathered a 3 and gone home with it, we would have just said, well, she had a 3. I don't know what that meant. But now that we've talked to her, she really wasn't but she really wasn't Again, I'm still confused. So we really don't mean, excuse me, sometimes we don't get what a participant is trying to say with numerical data. Unfortunately, though, sometimes we need to do data collection quickly, and we have to resort to quantitative. So when is it that I want to use qualitative versus when I want to use quantitative? Well, if I just want something quick and dirty and I just need a number so I can apply statistics to it, I'm going to use quantitative because that's numerical responses. If I want lots of detail that I have to kind of sift through to really get an idea of what that person is going through, I'm going to have to use qualitative data. So it kind of depends. And that's kind of one of the punchlines for this semester that you guys are going to notice. And at the end of the semester, I'm going to tell you, so to kind of wrap it all up, there is no real one statistical method or one research design method either that really is the ideal or perfect methodology. They all have limitations and they all have advantages. And at the end of the semester, you're probably going to feel like, oh, I really thought you were going to wrap up with like, this is the best way to do it, or that's the best way to do it. This is the most up-to-date method of collecting data that's accurate. Now, I can't do that because these are all techniques that we use and they all have limitations. The next terminology that I want to introduce is the issue of discrete versus continuous data. Now, for discrete data, essentially this means that we place individuals or responses into specific categories or numbers. So we can't really have fractional values. So think of it here in this particular case. Think of it like your status as a freshman, sophomore, junior, senior, or other. Okay? So in other words, we're going to place you into a category such as junior. You're a level 3, right? Because that's your category. And that's the only place that you can be on, right? So you can't be at 3.1. So you can't be like, well, I'm a junior, but I'm much closer to being a senior. No, you're a junior, and that's that. So a senior is a senior, a junior is a junior, a sophomore is a sophomore, a freshman is a freshman. Okay, so that's the aspect of a discrete data, right? That you can be placed into categories or into specific numbers, and you can only be in those numbers. You can't have fractional values. You can't have decimals or anything like that. Now, with continuous data, on the other hand, you can have fractional values, or you can have values that fall on a number line, and that's very important for us. So in other words, let's say, for instance, that you take an exam, and the exam scale goes from a 0 to 100, but you can technically get an 82.3. Right? So if you are given partial credit for your responses, you can technically get an 82.3, an 84.5, you can get an 85, you can get a 92.9, or whatever the case may be. So you fall anywhere within that number line. Okay, that's very important for us. Last two terms that I'm going to introduce, very, very important terms for us that we need to learn right now, and these are going to be imperative for you to know for the remainder of your career. Are independent variable and a dependent variable. Very, very, very important. Independent variable, this is what we also call the predictor variable, or we also sometimes call this the influencer. So in other words, this is the variable that we assume is going to have an effect on something else. Okay? Now, be very cautious with this. Many times in research methods courses or in science courses, so for instance, think back to when you actually took your first science-based class, right? So when you did your poster session for the science fair, and they started introducing the terms independent variable and dependent variable, they probably said that the independent variable was the variable that you manipulate. That's normally the way that people describe it. That's half true, okay? So here I'm telling you that there is another face or another part to this aspect of an independent variable. The independent variable in a research question or in a research study is the variable that you can manipulate or sometimes that you observe. It's the one that we assume is going to have an effect on something else or that may potentially affect something else. Okay, very, very important. So, give you two examples of this. So let's say, for instance, the effect of temperature on aggression. Okay, and temperature here, I'm in control of temperature, so I can manipulate temperature.
So using the following sentence, the effect of the IV on the DV is going to be a good sentence for you to be able to use that's going to be able to help you identify which one's your independent variable and which one's your dependent variable. So here very quickly, let me go ahead and write out that sentence for you so that way you can be able to identify where it is that we put each one of our particular terms. So here, the effect of the IV or the independent variable on the dependent variable, or the DV. All right, so here I've already introduced for you this idea of the independent variable. With our independent variable, remember, this is the variable that we assume that we're going to be able to manipulate or that we're going to be able to observe. And again, remember that we don't always manipulate the independent variable because there are certain situations where we're not able to manipulate the independent variable, that I'm not in direct control of it, but it still acts as my predictor. It still acts as the influencer on my dependent variable. So one of the things that you always have to think about in a research situation or in a question that you're posing, so for instance the effect of temperature on aggression, here if we look at the order of the effect of aggression on the effect of temperature on aggression, temperature here would be my independent variable because that occurs first in my sentence, and then dependent variable in this particular instance would be aggression. And here you have to also think about the logical order of your variables. So in this particular instance, if you were to put aggression first and then temperature second, how does aggression affect temperature? Now here, unless you're talking about internal body temperature, then I would be okay with that. But if you're talking about ambient or environmental temperature, it's not going to be feasible, right? That's not possible. For the more upset that you get, the hotter it's going to be outside or anything like that, because there is no relationship between that, because you're aggression level cannot have an effect on temperature in terms of the environment, but the temperature that we actually have outside may potentially affect our aggression levels, because the hotter that it may be or the colder that it may potentially affect the way that we actually behave in terms of our aggression levels. So here, using this particular sentence, the effect of the IV on the DV is going to be a very important sentence that we're going to visit time and time again this semester, because it's going to be core to understanding which one's my predictor, or what we also call my influencer, the independent variable, and then also understanding which one's my dependent variable, or the one variable that I'm measuring. We also call that the criterion variable. Now here, with our dependent variable, we have to think about the variable that we are measuring. So in your science fair projects, many times what you would say is, if I add water or different amounts of water to these plants, which plant grows the most, right? You would maybe make a sentence in regards to that, or you would make a question in regards to that. So here that you would say, well, one plant gets 5 milliliters of water, another plant gets 100 milliliters of water, and another plant gets 500 milliliters of water. Which plant is going to grow the most? Essentially here, the water is the independent variable, because that's the one that's changing, or the one that we assume is going to have the effect on the growth of the plants. So in that particular instance, the growth of the plants would be the dependent variable, or the variable that we're measuring here, the one that we call the influenced, or the criterion variable. So here, in terms of our sentence, we would say the effect of watering on the growth of plants. And in our particular case here that we're using this sentence, the effect of temperature on aggression. Aggression is what we're measuring our participants on. That's the behavior that we want to see how it is being expressed, and we want to be able to observe how many times does aggression occur in terms of physical acts of aggression, how many curse words they may use in terms of verbal aggression. We may even want to give them a questionnaire that measures aggression as well. And throughout the semester, we'll also talk about how we can use different scales to be able to measure the exact same concept. So here, for instance, physically observing how aggression occurs in terms of number of physical acts, or counting how many words that they're using that are going to be considered aggressive, or giving them a survey associated with aggression. All of them measure aggression in different capacities, but yet they all still measure that same idea, or that same construct associated with aggression. So here, two very, very important terms for us in terms of the way that we think about designing research questions and then being able to collect data. Because here you have to think about this. I need to collect data right here. In terms of the dependent variable, I need to be able to collect that data. So I need to collect those numbers, because that's what I'm going to do my statistical analyses on. Because if you think about, for instance, how much water I give to a plant in terms of its growth, here, if we give one 5 milliliters, another 100 milliliters, and then another one 500 milliliters, I'm now comparing three groups on the growth. I now have to make a decision about how much growth is actually occurring, and if there are extreme differences between 5, 100, and 500 milliliters of water, because that's really what statistics are all about, that we're trying to figure out, are there differences between our groups, are there relationships between our variables, or whatever the case may be, and I have to be able to collect specific data. And the dependent variable, the data that we're going to collect there, is going to be vital for us to be able to answer those specific questions. So again, here, very, very important terms that we do need to visit in terms of what it is that we're working with for statistics this semester. Now, also, we need to just talk very briefly here about some statistical design issues, or terminology here that we need to visit. Very, very important terms that I'm going to be introducing here that are going to be vital to our understanding of statistical analyses for future discussions that we're going to be having in the semester. So if you've skimmed at all the contents of your textbook, or even looked at the topics that we're going to be covering this semester in terms of the course syllabus, you'll notice that towards the end of the semester we talk about some very important statistical analyses. We talk about what are called t-tests, and we also talk about what are called ANOVAs. And within t-test and within ANOVA, we talk about different types of participation. So how do people participate? So when we think about statistical analyses, there's this core relationship and a very integral part of this relationship associated with research designs. So the way I set up my research study is ultimately going to affect the way that I'm going to analyze my data. Very, very important. So in other words, the way that I'm going to collect the data is going to affect the way that I'm going to analyze that data. And many times we don't really think about that. Many times what we say is, well, I just collected the data, now what do I do? Well, you collected the data, but you have to think about how you collected that data. Did you compare groups? If you compared groups, how many groups did you compare? Because if you've gone through your table of contents at all in terms of your textbook, and you've read a little bit of a snippet of what a t-test does, or if you get a chance to do that now, a t-test compares only two groups on one common dependent variable. So for instance, comparing 5 milliliters of water for a plant and 100 milliliters of water for a plant in terms of the plant growth, comparing only two groups. But an ANOVA lets you compare 3 or more groups. So for instance, 5, 100, and 500 milliliters of water on the plant growth. So here it's going to be very, very important to understand, well, how many groups am I comparing? We also have to understand what kind of participation are individuals having, because when we think about how we participate, some very important terms come up. So let's say, for instance, that you are an individual who's going to be coming into a research situation and you're going to participate in a study. All right. So when you come in to participate in a research study, what we're going to tell you is we say, hi, Betty. And here we have Betty who's going to be participating for us. Betty, what we would like you to do is we would like you to come in and we would like you to listen to, I don't know, let's say soft rock. Okay. So we're going to listen to soft rock. So SR. And what we're going to now do is we allow Betty to listen to soft rock for about 5 minutes. And then what we do now is we measure her aggression level. Okay? So we see how many times she acts physically aggressive or verbally aggressive during a 20-minute period. Okay? So within 20 minutes, how many aggressive acts does Betty commit after listening to soft rock? And then what we do is we say, all right, Betty, now that we're done with that, what we would like for you to do is we'd like you to listen to thrash metal. Okay, so here this would be considered our heavy rock or thrash metal, whatever it is that you would want to consider that. So here we have another group. So we now expose her, same individual, Betty, to also listening to another type of music for 5 minutes again, and then we measure her aggression level again for 20 minutes. So exactly the same process as we did with the soft rock, but now all that we've changed here is the type of music that they're listening to. So first she listened to soft rock, and now she's listening to thrash metal. So in this particular instance, if we were to use our sentence that we used on the previous slide, the effect of the IV on the DV, think about what goes in the IV slot and think about what goes in the DV slot. Okay, so here I'll write out the sentence again for you. The effect of IV go on DV. Okay, so here if we had to fill this information in, think about what goes in my IV slot. So what is it that I may potentially be manipulating or observing? And in this particular instance, what I'm manipulating is I'm manipulating the type of music. So here, the music, it being soft or thrash metal rock, is going to be my independent variable. Okay, my predictor. So the one that I assume is going to have an influence on whatever it is that I'm measuring. And what is it that I'm measuring? My dependent variable, I'm measuring the regression levels. Okay, so here using this particular sentence allows me to be able to again identify what's my independent variable and what's my dependent variable. Very, very important that we identify both of those in any research situation that we're presented with and any statistical situation that we're presented with. And throughout the semester, I'll continue to visit this idea over and over and over again. So now, if you've noticed, something very important has happened to Betty. Betty is in both of my groups. That's an important factor here to consider. Why is it important for me to consider that having Betty be in both groups is important? Well, because Betty's the same person. So if Betty comes in and she listens to soft rock, and then 5 minutes after we give her the aggression assessment, we now put her in the thrash metal group and give her her assessment again. So only 5 minutes has elapsed between the time where we gave her measurement after listening to soft rock and then listening to the thrash metal. Only 5 minutes has changed. nothing really drastic should happen to Betty in terms of her ability to change as a person. So here we assume that as years go by, we change, right? We change very little, but we do change. So how do we change? We may change in terms of our health. We may change in terms of some behavioral aspects. We may become more responsible as individuals. We may implement strategies to learn information. We may learn how to cope better with difficult situations. Who knows, right? Across years that happens. But within a 5-minute period, I don't expect that anything like that has happened to Betty. Okay? But Betty's the same person. So here, if I do find that Betty's aggression levels change, so here for instance, let's say that in 20 minutes, she performs 8 aggressive acts. After listening to thrash metal, she performs 20 aggressive acts. If I find that there's a difference between 8 aggressive acts and 20 aggressive acts, in contrast to these two groups, right? So the soft rock versus the thrash group, I'm going to assume that the difference is going to exist because of the music itself, not because Betty drastically changes from one group to the next group. Because if you notice, the only main difference between the two groups for this one particular person is Betty. The groups change, but Betty remains constant. Since Betty remains constant, we wouldn't expect her then to be the influencing factor in terms of the aggressive acts. So within those 5 minutes between when we took her aggressive measure after listening to soft rock and then her listening to thrash metal, I wouldn't expect that Betty should have changed and decided on her own, oh, I think I'm just going to naturally become much more aggressive to individuals. I really don't like people. I'm just going to say really mean things, or I'm going to hit people all on her own. But rather, if we do see an increase in her aggressive acts like we observed here, with now having 20 aggressive acts after listening to the thrash metal group, we're probably going to assume then that the difference exists because of the music itself, not because Betty changed. And that's a very, very important factor. Now, with that being said, is there always going to be a situation where we allow every single person to be in all of my groups? And the answer is no. So take a situation, for instance, where you're going to compare men and women on, let's say, motivation. Okay, so here, let's say that we're going to say the effect of, and again, we're going to use the same, the IV on the DV. And here in our particular case now, we're going to say gender is my independent variable, and my dependent variable is going to be motivation. Okay, so we as researchers are interested to see if men and women differ in terms of their motivation levels. That's really what we want. Now, if you remember from our previous slide, I talked about this difference of having independent variables that could be manipulated or observed. In our particular case down here with the music issue, I am in complete control of the music that I'm playing for Betty in this particular instance. But if I look at this particular factor here of gender, can I manipulate a person's gender? And the answer is no, right? Ethically, we can't do that. Maybe scientifically we can, but ethically we're not going to do that. So here in this particular instance, we are saying you come in and you report that you're a male. I'm going to believe that you're a male, and I'm going to put you in the male group. You come in and you say that you're female. I'm going to say yes, that you are a female, and I'm going to put you in the female group. That's as best as I can do because I'm observing that variable when you come in, that you say to me what group it is that you should pertain to. Very important. I should never have a preconception or a bias as to what group you should pertain to ahead of time. So let's say, for instance, an individual walks in and they're clearly female. If they say that they're a male and they want to be in the male group, I cannot say, no, you are clearly female. You need to go into the female group, because here we're basing ourselves on whatever the individual reports. Now, if you have a concern that you potentially think, that person was just messing with me, they're just being mean-spirited, or they may not really be a representation of the population that you're interested in working with. So, for instance, you really want females, but this person reports that they're a male. Here in this particular instance, they may not be a good representation then of the female population, because they're reporting a different gender. Their gender identity may potentially be different. Here, you may want to just flag their data and maybe hold it out because they represent a different population, and it may potentially affect your results, giving you different results than what it is that you expected because they represent some different group. So here, if you're ever concerned with data that you're collecting, that people may be messing with you, so for instance, Betty in this particular instance, that now she's just making more aggressive acts because she's just acting up or whatever the case may be that you really don't feel is because of the music, you may potentially hold out Betty's data and say, yeah, Betty, we're gonna hold out your data here and we're not really gonna use it. In this particular instance, same thing would happen. A person comes in and they report a different gender than what they look like. You may potentially get concerned and you may want to hold out that data because you have concerns about the quality of that data. But here again, we're not going to be questioning individuals and saying, no, 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 you're clearly female, or no, 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 you're clearly male, so you have to go into that group. We just go with whatever it is that they said. So in that particular instance, I am not in control of the individual's gender. So here, rather than having a manipulated independent variable, I have what's now called observed independent variable, that I'm observing that particular factor and I'm assuming that that independent variable is potentially still going to have an effect on my dependent variable, in this particular case, of motivation. So here, let's say, for instance, we now have Gary that comes in, and Gary is a male, right? And we measure his motivation, and we find that out of a 10-point scale, Gary is an 8 in terms of motivation. Now, Mary comes in, and Mary reports that she's a female, and Mary has a motivation of 9. Perfect. So here you'll notice that Gary is only in the male group and Mary is only in the female group. So Gary cannot be in the female group, Mary cannot be in the male group. Okay? Why? Because these groups are mutually exclusive. Okay? In this particular case, even though these groups are mutually exclusive, they don't have the limitation that I can't have the same individuals participating in both groups. I can do that, especially that I'm in control of this particular variable of music. In this particular instance, I'm not in control of the variable of gender, so I cannot put Gary in the female group and I cannot put Mary in the male group because that's just not logistically feasible in this particular instance. Now, the way that I've structured both of these experiments represent two key ideas that we use in terms of research designs. Now, in the case where you have individuals being a part of mutually exclusive groups that they cannot be in another group, this is what we're going to call a between groups research design. A between groups research design. Okay, and I'm going to talk much more about it in just a minute here. So between groups research design. So here, having mutually exclusive groups. So participants in one group can only be in one group of the experiment. They cannot be in another group of the experiment. They can only be in one. Now, in the case where you have a participant, such as Betty in our case, that is in all of the groups of your experiment, we're going to call this a within groups research design. So within groups research design. Okay? Why is it called a within groups? Because here we're comparing individuals to themselves within the groups. So Betty gets compared to Betty. And that's a very, very important point here that we have to make with a within groups research design. That Betty gets compared to Betty. Okay? Why? Because who's the best representation of Betty? Betty is. The only difference between the two is the music that they listen to. So why would I ever want to compare Betty to Luis? Luis is another individual who was in both of the groups as well, but here I wouldn't want to compare Betty's score in the soft rock to Luis's score in the thrash metal because they're naturally different. And that's a very important point here that we have to make, that people are naturally different. Even think about your siblings if you have siblings or cousins or whatever the case may be, or even the person that's sitting right next to you in a classroom. Here, even though you may be of the same gender, so you look at each other and you're like, oh, we're both male. We're identical. And the answer is no, right? Why are you not identical? Your age may be different. Your height may be different. Your weight may be different. Your socioeconomic status may be different. Your educational background may be different. The classes that you're taking, aside from the one that you're currently in, are going to be different. The professors that you have may potentially be different, etc., etc., etc. All of these different components and factors are ultimately going to be creating differences in my scores. So this is very, very important. Let's say that we have two individuals, okay, Gary and Mary. Gary is 28, Mary is 28. Gary is a banker, Mary is a banker. Gary is from San Antonio, Mary is from San Antonio. So a lot of the same things that are occurring, right? So here, one of the things that we can look at is if we say Gary and Mary are different in terms of their scores, if that's what we concluded, that Gary and Mary differ in terms of their levels of motivation, but yet everything else is equal except for their gender, I would assume then that the differences in their scores would be due to their gender and not another factor. Okay? So again, I'll say this, very important. So here, if Gary and Mary are equivalent on everything, on every single possible thing that exists out there in the world, except for their gender, and we find that their motivation levels differ, so Mary is more motivated than Gary, we would then assume that the difference is due to gender differences and not due to other potential differences. So let's say, for instance, that Gary has no kids and Mary has 2 children. If that difference then occurs, we may say, well, the motivation differences between Gary and Mary may potentially be due to their gender, but it may also potentially be due to other factors, such as them having differences in kids. Because Mary may be more motivated to work harder and do well in her job because she is providing for her children. Gary, on the other hand, doesn't have any kids. So for him, he may not really want to care or doesn't really care that much and doesn't work too hard because he doesn't work for anybody else but himself. So here, really, he has no additional motivational factors, right? So if differences then exist between the individuals, naturally, we call those differences individual differences. Okay, individual differences. What are individual differences? Individual differences are differences between individuals that naturally occur, and they may potentially affect my scores. Okay, very, very important. So here, let's try out another example here. So again, let's say that we now have Gary and Michael. Okay, so Gary and Michael are both male. Gary is 18, Michael is 18. Gary lives at the dorms. Michael lives at home. Gary is employed. Michael is unemployed. Gary is in statistics. Michael is also in statistics. Okay? So here you'll notice there's a lot of similarities between Michael and Gary, right? Here, they're both male, right? That's a key thing here that we were looking at, that both of them are male. So since both of these individuals are male, I would expect them to have the same motivation score, right? Because here, I'm looking at the motivation average for all male individuals. So all males, I would expect then to have a similar score in terms of their motivation. So here, Gary has a motivation value equal to an 8. Michael has a motivation value equal to a 5. So here, you may think to yourself, well, why is there a difference then between Michael and Gary if they're both males? I would expect both of them to have the exact same motivation score because they both represent the same group. True, they both represent the same population of being male, but yet Gary and Michael differ because there's some other differences between the two. One of them lives in the dorms, one of them lives at home, one of them is employed, another one is not employed. So potentially, Gary living on his own in the dorms and being employed helps him have a higher motivation score than Michael, who lives at home and is unemployed. So here you'll notice that even though they both come from the male group, so both of them are coming from the male group in this particular instance, they still are different in terms of their scores. Why are they different? Because they have individual differences. What are those individual differences? Those individual differences are ultimately differences between the two individuals that are just inherently there, that they are not identical to each other in every single capacity. These individual differences lead to what is called error variance. Error variance. What is error variance? Error variance are differences in our scores that are not due to the researcher's manipulation or control. Okay? That's what error variance is. Individual differences lead to error variance. Error variance are differences between my scores that are not due to my researcher's manipulation or control. So in other words, if Gary and Michael were identical to each other in every single way, male, 18, both live in the dorms, both are employed, both are in statistics, everything else is identical, I would then expect their scores to be equal to each other because they both are identical to each other. The only thing that's different is their name, right? But yet here, we find that their scores are not equal to each other in this particular case. Why? Because they have these individual differences. These individual differences lead to error variance. That error variance are differences in our scores that are not due to the researcher's manipulation or control. Okay? Very, very important. In your textbook, they refer to this sometimes as sampling error. So in other words, the people that we sampled, there we go. Okay, I'm having a little bit of difficulty. There we go. Sampling error. Sampling error essentially is the same thing as error variance. It's just another name. I like to use error variance, but sampling error is the exact same thing. That the people that we grabbed from the population, the people that we sampled from that population, may inherently just be different because they have individual differences. Okay? That's ultimately what we're talking about in this particular instance. Okay? So sampling error and error variance are identical to each other. So now getting back to our particular example here that we were talking about, so then looking at this difference between Gary and Mary, we may find that the groups do differ, but potentially the difference between Gary and Mary, beyond just the gender differences, may potentially be due to other factors. So here, I want to minimize these individual differences. I want to minimize error variance. I want to minimize the differences that occur between my groups that are not due to the researcher's manipulation or control. So in other words, I want the differences between Gary and Mary to be due to what? The differences of their gender, not differences in terms of who they are, how old they are, where they live, how many kids they have. That's what I don't want. So here, having a between groups research design where you use different individuals in different groups leads to higher error variance. Okay? So again, here now, having a between subjects research design is going to lead to having higher error variance. Why? Because I'm using different individuals for the groups. Okay? So in other words, Gary is in one group, Mary is in another group. Naturally, they are just different individuals. Thus, we're going to have differences that exist between my groups be higher because I'm using different participants. Now, in the case where we have Betty, that Betty is being used in both the SR and also in the TM group, so in the soft rock and in the thrash metal group, I'm going to have less error variance. So here, having a within groups research design, leads to lower error variance. Why would it lead to lower error variance? Because I'm using the same people. So we're using the same individuals in both groups. So since I'm using the same individuals in both groups, thus I'm going to have lower error variance. So Betty should not drastically change from the SR group to the TM group. The only thing that changes between the SM and the TR group is the music, the SR or the TM. So thus, if we do see differences in terms of her aggression, just as we've observed right here, I would expect then that the differences that existed between SR and TM are due to my manipulation or control. What do we call that? We call that effect variance. We call that effect variance. So here, sorry about that, guys. I didn't like the way I wrote that. Effect variance. What is effect variance? Differences between our scores. So here you can assume between the groups. So differences between my scores that are due to the researcher's manipulation or control. So in other words, if I do find that differences exist between Gary and Mary and between the SR and the TM group, I'm going to assume that the differences are due to my manipulation or control. So I'm going to assume that if Gary and Mary differ in terms of their motivation levels, I'm assuming that the difference is due to their gender, not due to other factors. Down here, if there are differences between SR and TM, I'm going to assume that the differences are due to my manipulation, the music, not due to other potential factors. So here, using the same individuals leads me to believing to a greater extent that the differences that exist between the groups are actually due to my manipulation or control, since I'm using the same individuals. Up here, with the between groups research design, I have less confidence of that decision, because potentially, since I'm using different individuals in the male and in the female group, potentially the differences between those individuals may just be due to other factors such as individual differences and not due to my manipulation or control. Very, very important issues that we have to address in this particular instance. All right, so let me go ahead and just delete all this stuff that I have right here on the screen, and now let's just here recap or revisit those specific terms that we just covered. So with the between groups research design, participants can only be in one condition of your experiment, such as in our example here with male versus female groups that we're comparing on their motivation levels. Gary can only be in the male group, Mary can only be in the female group. With the within groups research design, participants are in all of our conditions or groups of our experiment. So here, whenever I use the term condition, I essentially mean groups. You'll also hear me use the term levels. Levels refers to conditions, also refers to groups. So here with the within groups research design, all participants are in all my groups or in all of my conditions, such as in the case with Betty, that she's in the SR and also in the TM group in this particular case. So we've covered all these basic terms. Where is it that we talk now about statistics, right? Because we've been talking for a little while, but yet we still really haven't talked about stats. So where do stats really come in? So with statistics, statistics are very important because they're going to help us organize, summarize, and also interpret numbers that reflect measurements or data. So in our particular case here that we were looking at the differences between men and women on motivation levels, using statistics is going to be very helpful for us to be able to organize information and say to ourselves, all right, well, how much motivation does this person have on average? And also as a group, what is the average motivation for all males? What's the average motivation for all females? So helping us really organize that information and summarize that information as well. Because one of the things that you have to think about in terms of statistics is that if we are going to be trying to draw conclusions about the differences between men and women on motivation, or between the differences between soft rock and thrash metal on aggression scores, it's not fair for us to only get one person to come in and participate, but rather we need hundreds, thousands of individuals sometimes to come in and give us their data so that way we can draw appropriate conclusions about the population. And I'll talk a little bit more about this issue of the population in just a bit. So when we think about statistics and what are statistics, there's a very good reason why we call this class that you're taking statistics. And the reason that we call it statistics is for the following. Statistics in themselves are what we call point estimate representations of population parameters. So in other words, statistics are going to be a representation of the overall larger population. So in our particular case where we were comparing men and women on motivation scores, if we have 20 individuals who come in and make up my male group and 20 individuals come in and they make up my female group, those 20 individuals are then going to act as a representation for the population. So think of it like, for instance, with our state representatives. We have state representatives who go and represent us in the Senate or in Congress or whatever the case may be. They go and represent us. One person represents an entire population or an entire area or an entire state in some instances. So is it really fair for us to only have one individual be able to do that? Probably not, right? But if we had 20 individuals who were a representation of the state, that would be much more representative than one single person. But yet, those individuals are going to be a representation of the ideas of the community. So the same thing happened here with statistics. If we have 20 individuals who come in, who participate in my male group, so here we say for our males, we have 20 individuals, and for females, we have 20 individuals. We then would use these 20 individuals and their results to draw conclusions about the male population. Okay? These 20 females, whatever their average would be in terms of motivation, would be a representation of the female population as a whole. So in other words, we aren't going to be able to go and get all males, all females to come in and participate from the population because that's just too many individuals. But rather we grab a subset, a sample of individuals to come in and be a representation of that population. So here, whatever values it is that we calculate for my samples, we're going to call those values statistics. So statistics are going to come from samples. And that's a very important issue that we have to address here. That statistics come from samples. So in other words, we have an entire group of individuals, population, so thousands, millions, billions of individuals in some instances that make up the population. But yet from them, we grab a subset of individuals that we sample. Those individuals that we randomly sampled from the population are going to be what we call the sample of individuals. That sample, those 20 individuals that we have here that represent the population, any numbers that we calculate from them, so average motivation, average self-esteem, it doesn't matter what numbers it is that we calculate, whatever values it is that we calculate from this group of samples, we're going to call those values statistics. Statistics always come from samples, very, very important. Those statistics are going to be a point estimate representation of the population parameter. What is a population parameter? It's going to be the value that represents the entire population. So here, let's assume that we actually went out and got 4 billion males to participate and 4 billion females to participate. Let's say that we captured all males and all females from the entire world to come in and participate in our experiment. Very unlikely that this would ever happen, but let's assume that this did happen, right? So if we assume that these individuals came in and participated, all individuals who are male, all individuals who are female, and they gave us their data in terms of their motivation, the values that we would calculate for all male individuals, the average value for all males from the population would be considered a population parameter. Okay? Why is it called differently than a statistic? Because a parameter represents all individuals from the population. The statistic represents only the individuals that we sampled from the population. Okay? Now, since it's highly unlikely that I'm ever going to calculate a population parameter, so it's highly unlikely that I'm ever going to have the population come in and participate. Rather, what do? I'm going to depend on gathering a sample and calculating statistics. That's what I'm going to do because that's feasible for me to do. So in other words, I'm going to go out and I'm going to go randomly sample 20, 200, 2,000 male individuals. So even though I'm not getting the entire population, I'm still getting a subset of the population that I'm going to assume is a good representation of the overall larger population. And whatever the average is for all males, that's what I'm going to assume the population parameter would be for all male individuals in the population. So again, if we calculate the average for males from my study, okay, so from my experiment, and we calculate that the average motivation for men is an 8.2 out of 10, and for females, we calculate that the average is equal to a 9.3, we then assume that this average of an 8.2 is a statistic because this is only a representation of these 20 individuals here. 9.3 is a representation of these 20 females here in terms of their average motivation, but yet this statistic here is going to be a point estimate representation of the population parameter. In other words, if we were to go out and get all male individuals to come in and participate, I would expect that their average would be somewhere around an 8.2. Why would I expect that? I would expect that because in my study, with my individuals that I've randomly sampled, I calculated an 8.2. So I would assume that since my individuals that I've sampled from the population are a good representation of that population, I'm then going to assume that my parameter would also be around the value of my statistic. So in other words, it's a point estimate representation. Now here, it's an estimate. It's not an accurate or an exact value. Okay, we never say that. We never say it's an exact value of the parameter, but rather it's an estimate. So in other words, our value in the population, my population parameter is going to be around an 8.2. It may be an 8.1, an 8.0, a 7.9, an 8.3, an 8.4, but somewhere around the 8.2 range. It should never be drastically different and extremely different from my value of an 8.2 that I've calculated in my study. Because then again, remember, my males that I've calculated my 8.2 from are supposed to be a representation of the population. So if in the population, my actual motivation for all men is a 4.3, now I have a problem. Why is it that my males in my group, in my study, have an 8.2 average, but out there in the real world it's a 4.2? And then, to be honest with you, I really don't even know it's a 4.2 because I can't calculate that number. It's too many individuals. But rather, I'm going to use my statistic to be that estimate of the population parameter. So again, what's the relationship between statistics and population parameters? Statistics are point estimate representation of population parameters. What are stats? Stats come from samples. Population parameters come from populations. So population parameters represent the value for the entire population's behavior or their entire score. Okay, that's the key issue here. So in terms of all of our discussion here that we've been talking about research designs, terminology, and all these different things, why is it that statistics are important to us? Statistics are important because it gives us values that we can work with in a real world setting, right? Or in a real situation, because it's unfeasible for me to get everyone from the population to come in and participate, but rather I can work with a sample of individuals and I can calculate statistics. Once I calculate those statistics, then I can draw conclusions about the population parameter because I'm assuming that my statistic is going to be a representation of that population parameter. Okay, and that's very, very important relationship here that we realize between the two. Now, why are statistics so important for us? What again is going to be the purpose for statistics themselves? Remember that stats are going to be our estimates of our population parameters. So in other words, I can feasibly calculate a statistic and I can estimate the population parameter based on my estimate of my statistic. Now, why is this class then called statistics and not parameters? Our class is called statistics because that's who we work with. We work with samples. We don't work with populations. We infer about the population, and I'll talk about that in just a second here, that we infer about the population using my samples, using my statistics. I make inferences about the population, but I directly do not work with the population because it's very unlikely that I'll ever have the population come in and participate because logistically speaking, it's impossible. So the intention of all psychological studies, in terms of our work, in terms of statistics, is really to generalize our results to the entire population. We call this external validity or generalizability. You'll hear that term being used interchangeably. So how well do our results apply to a real-world setting? In a real situation where we would be collecting data, we want to make sure that we are going to have our results be reflecting the population work or the population behavior as best as it can. Because that's the idea of psychological research studies, that whenever it is that we do research studies in the laboratory or even in the field, we hope that the results translate to the overall larger population. So in other words, we have external validity. Why would I want that to happen? Think about that for a second. Why would I want the results from my study to apply to the larger population? Well, remember, the people that you got to participate in your study are supposed to represent the population. So at the end of the day, I really don't care about the 20 men and the 20 women who came in and participated in my research study about motivation, but rather I care about the population. I'm using those 20 individuals from each group to draw conclusions about motivation differences between men and women out in the population, but I'm using these 20 individuals per group in my specific situation. So here, I really do care about the population, but I use samples to draw conclusions about the populations. That's really what we're doing. So what's the best way for us to estimate the entire population? It's going to be through statistics. And that's why you're taking this class, because you essentially have to learn how it is that we talk about the population, but using samples and calculating statistics. That's very, very important. Now, statistics have two very important roles that we're going to be covering this semester. Our entire class is structured around these two roles. The first part of our semester is really going to be associated with the first role of statistics. The second part of our semester is going to be associated with the second role of statistics. So what are those two roles that we're going to be talking about? Broadly, statistics can be categorized into two basic categories depending on their role in a research situation. So what's the purpose of the data that we're collecting? The first role of statistics is really to describe individuals or to describe my sample. We call these descriptive statistics. So you've noticed here we're not very creative in the naming process of our stats. We call them descriptive statistics because they describe the sample. So here, descriptive stats describe the sample. They focus in on the sample. Why am I not saying descriptive parameters? Because again, I cannot get the entire population to come in and participate, but rather I have the individuals from my sample that I've randomly sampled from the population to come in and participate. So here I focus in on the sample, but I want to describe them. How can I describe them? The way that we describe our sample are through three general ways. We use what are called measures of central tendency, measures of variability, and simple relationships. Those are our three measures of descriptive statistics. So again, measures of central tendency, measures of variability, and simple relationships. Those are going to be my three methods to be able to describe my sample. So what are measures of central tendency? This semester, we're going to cover these three measures of central tendency. We're going to talk about the mean, median, and mode. Here you'll notice that I have the symbolic notations associated with the mean, median, and mode. The mean is categorized as capital M. This semester you'll also see me use what is called X bar, so it's an X, capital X with a bar over it. That's a representation also of the average. So if you ever see me use X bar, it means the same thing as capital M. But capital M refers to our mean, so we're going to talk about how to calculate the average, how to calculate the mode, and how to calculate the median. Okay, what is the mean? That's the mathematical average. The mode is the most frequently occurring value in our data set, and the median is the middle value in our data set. Right now, you're probably thinking to yourself, oh man, this is the part where I start hating statistics because now we're starting to get into the actual stats part. And you're right, we are going to start getting into the statistics part, but do not worry about this, guys. This is basic statistical procedures that we're going to be covering this semester in terms of our descriptive stats. And they're very, very easy to calculate once you understand the formula. And formulas here, they seem like they're very difficult. I always compare them to a dog who barks and barks and barks. They look very threatening, but then you go up to the dog and you pet the dog and the dog is very docile. Same thing here happens with statistical formulas. They look very intimidating. They look like if they got a lot of bark behind them, but in reality, they are very docile and they're there to help us. Statistics and their formulas are there to help us. They are our friends. They are going to answer the questions that we have associated with our research questions. So here, measures of central tendency, we're going to begin to cover those next week. Measures of variability, in 2 weeks we will cover measures of variability. Those are going to include range, standard deviation, variance, and standard error. Very, very important measures of variability. And last, towards the end of the semester, our last chapter that we're going to cover this semester, chapter 15, I believe, is simple relationships. And that is what's categorized as our lowercase r. This is our Pearson product moment correlation statistic. So right now, don't necessarily worry about what these statistics are or how to calculate them. Just know that they fall under the domain of descriptive statistics, that their purpose is to describe my sample. So I want to describe my sample in terms of the average performance for my group, the most frequently occurring value for my group, and also the middle value for my group. Measures of variability. Measures of variability talk about what we call dispersion. Okay, that's what variability means to us, dispersion. How far apart are my scores from each other or from some central point? So here we use these different measures to be able to identify that. How far are my scores from some central point? And last, simple relationships. What's the relationship, the magnitude of the relationship, or the strength of the relationship between potential factors? And we're going to talk about those a little bit later on. The last role of statistics is to infer, or what we call inferential statistics. I told you guys, we are not creative in the naming process. So we want to infer. What do we want to infer about? We want to infer about the population. But aside from inferring about the population, what specifically do I want to infer about the population? I want to infer about what are called the nature of the effects. For now, just know that inferential statistics infer about the population using statistics. Okay? So we're going to infer about the population using stats. What am I going to infer about? I'm going to infer about the nature of the effects that exist outside. So in other words, I'm going to infer about the real world. That's essentially here what I'm talking about. So I'm going to infer about the results that exist in the real world. What results exist out in the real world? Either the groups differ or they don't differ. Either there is a relationship or there is no relationship. That's the results that exist out in the real world. So think about flipping a coin. When you flip a coin in the real world, it can only have two possible results. It either lands on heads or it lands on tails. Same thing happens with research. Either the groups differ or groups don't differ. Either there is a relationship or there is no relationship. Those are the nature of the effects. So inferential statistics, what I want you to know at this point is that we use statistics to infer about populations. Okay? We infer about groups' performance. So in other words, in my research study, I find that groups differ. Men and women differ. I'm going to assume that out there in the real world then, men and women differ. I would never say men and women differ in my research situation, but out there in the real world, they probably don't differ. It's like saying you flipped a coin, it landed on heads, and then saying, well, it landed on heads, but in reality, it should be tails. Well, then why did it land on heads? So here, whatever result we get in our research situation, that's what we assume exists out in the real world. Okay, and we're going to talk about some of those particular issues later on. Now, how do we actually draw conclusions about the population? So how do we actually make inferences about the population? We have a couple of different measures or ways that we actually do that. The first is through what we call mean differences. So in other words, we look at the difference in terms of two groups, so my t-test or my ANOVA test. So in other words, I compare more than two groups. Also, we look at multiple relationships. In terms of multiple relationships, we look at things such as capital R, which is just our multiple relationship statistic, partial R, partial correlations, or semi-partial correlations like we have here. This semester, we're not really going to talk about these multiple relationships. These are going to be tabled for classes when you take a graduate class in statistics or you take an advanced statistics course. You'll talk much more about those. We will talk about predictions though, so we will talk about what we call here our R squared value or my estimate of my measure here that we have, that's called our measure of determination that we have in this particular instance that ultimately is able to identify how much prediction we can have in our dependent variable from my independent variable. We will talk about that briefly. We will also talk very briefly about beta. We'll very, very briefly touch upon that this semester. And then we'll also talk about probability values. So we will talk about probability and how to calculate probability this semester. And we will talk about our probability value that we call lowercase p, which is just a reference to our probability. So we will definitely talk about these. So here we will definitely talk about mean differences, probability. We will talk briefly about prediction, but we will not talk about multiple relationships this semester. But these are all ways that we actually infer about statistics in our particular case. All right, so that wraps up our discussion associated with an introduction to stats. At this portion, I have added another video online within this week's module, which is our scales of measurement lecture. Please review both lectures because they both are in reference to this particular chapter. That is a very, very brief lecture. It's probably about 30 to 40 minutes long. Lectures are normally going to be about this length, guys, that there'll be about 2.5 hours per week. There are going to be some exceptions to those, but I try to split those into 2 different weeks so that way it's not too overwhelming. But normally there'll be somewhere around 2.5 hours worth of lectures because it'll cover the whole week for us. Please make sure to do your chapter readings. Please do let me know if you have any questions in regards to the homework assignments, and I wish you all well in terms of reviewing the lecture and our subsequent lecture for scales and measurement as well. So please reach out to me if you do have any questions, and I'll be happy to help you out along the way.